Start recording. Everything is running. Okay, good. So I think we rather better start because we will have not so much time for a lot of fun, I guess. So what's happening today? Last week we were kind of like for 1 hour talking about the theoretical side of artificial intelligence and mostly machine learning and algorithms and stuff. And today we want to just have a look how we using this actually in practice and some applications that are outside there. And we have 3 very interesting speakers today. And I think I will not introduce you guys. You will just tell who you are when time will come. Like, I don't know, I'm not used to kind of actually to hold stuff like that. Usually it's just like, oh, let's have a look how we're doing these things. And so we will talk about the 3 different applications, and each person will talk approximately some 15 minutes, maybe 10, and then we will have a look. Maybe there will be questions and stuff. And yeah, this is it. Our first speaker will be our ex-Trickstarian Alessandro Maschietto. I hope I'm pronouncing right.
Yeah,
from the plus 35 degrees. So Alessandro, take it away. You can share the screen. It's all yours.
Yeah. So just a second. Yeah. I forgot how to do this. So, this could be Diffusion. This is the other brother of Midjourney. My favorite, if I have to say it, because you have more possibilities, more chances of personalizing and like digging to the whole experience. So what is it? What do you need to do? It's not. It's completely different from the other ones. This is a Google Colab thing. So you just go on Diffusion, and it will load up the this Google Colab tab, and you can see like a bunch of lines of code, and this is where all the magic is happening. But so let's go with slideshow. So what is it? What, where, who, when, how? So it's an open source project, of course, via browser, as I showed you. There's lots of customizations, and the cool thing is that you can program it. So you can just put like a bunch of models doing, I don't know, you want trees, then you want cities, and then you want whatever. And you can just forget about it. The other thing is that you have 3 possibilities. You have one free, which has a 24-hour cooldown. One that is like the plus, the last 2 are subscriptions. There is the Plus and the Pro. The Plus, you get the nicer GPUs, and the Pro, you get the top tier. I don't remember the name, but they're like 32 gigabytes, super mega, eager, whatever, like super powerful GPUs, and you will get very complicated images in a matter of like minutes. So everything works via prompting. So you're talking basically to a stupid thing. It doesn't know what to do. You need to be as clear as possible, and you use the prompt. So when you load up the first time the tab, the Google Colab, you will scroll down and you will see the prompt, like the field that's called prompt, and this is the default thing. So it's a beautiful painting of a singular lighthouse shining. It's like a person to multi City of Blood by Greg Rutkowski and Thomas Kincaid, I don't know. Trending art station, and then you have like comma, and then you have another argument. So in the prompt can be organized in several ways. It could be linear, or it could be like separated by arguments. So you give like a general like structure of the 5 W's, for example. So it's who, where, what, when, and how. Or you can go on a single line and you describe as much as accurately as possible the what you want, and then you can add other arguments where you can give him, I don't know, for example, here it says yellow color scheme, or you can put, I don't know, movie, cinematic lighting, or ukiyo-e painting, or whatever. You can see there is a 0 and a 100. You can use it when you do the animations. For example, you can start from an egg and you can end to with bird, or you can start with a, I don't know, a rock, and you can end up with a present like a box. It's all up to you. Yeah. So this is the what I was saying, and these are the examples. For example, these are some example I did. This is from the cockpit of a futuristic spaceship, Cyberpunk City movie, Neil Levine, whatever, and then Hiromasa Ura, which is one artist from anime. Vitaly Bulgarov, I think we all know him, and matte painting is the style that I wanted to put. And then ArtStation. Why do we put ArtStation? It basically goes and scrolls the whole like site, and it's useful for the composition, lighting, not instead of staying of like being there and describe like I want this in the background, this in the foreground. Cool thing, you can also set focal length. Unless it does it automatically, for example, here we can see there is a kind of some depth of field with the focused stuff in the foreground. You can put, I don't know, Rockinon 50 millimeters 1.8 and focal plane background or background or whatever, and it will do everything. This is another one, A Geisha Walking Down a Road in Old Kyoto. Cherry Blossoms, Memoirs of a Geisha. Here, I gave him like two references for inspiration. So I gave him like Memoirs of a Geisha and Last Samurai. So it will go and scour the internet for these images, and then put it in matte painting. So the style changes, and then cinematic lighting with God rays. So it will try to put something, and it created this image. Here, the depth of field is kind of like all over the place, but I mean, this is supposed to be something where you start. So like you have a concept art, and you can go, okay, yeah, this is nice, so we can develop from it. This is a completely crazy one. I just gave him two words: flowers and owls, and the artist Max Ernst. It's a surrealist painter. It's basically merging humans and owls. And yeah, here you can see basically something that comes out from these two things. Um, Settings. Um, when you look at the settings, there are like tons of stuff that can be used. These are the main that will allow you to have something. So when you go through, I will demonstrate later. When you go through, you will have like the basic settings. So it's where you set the name, the steps, which are like the samples. If you guys used anytime, at any point, any 3D software, these are like the render samples. So the higher you go, the more the AI will go through and refine and refine and refine. The higher they are, the longer the render takes. Then there is the clip cadence scale, which is basically how far it's a number that sets how far the AI mind can go. So the lower, the further it can go. So for example, we have a bottle, and the AI can transform it into a mouse. The higher number, it's like I want a city and I want this kind of building. That kind of building would be there if I set it like for, I don't know, 50,000 instead of 5,000 as it's here. it's like a leash. Um, then your best friend is the IC power. This is basically the amount of details that you can have in the render. So, for example, this thing has a IC power of like 40 or 50, and there is like a lot of details. Like here, the old thingies. It's nice. This has like 25 or 30, and this is 10. Uh, I don't recommend like going below 10. This is kind of like RAM intensive. When you're using it, this software, you will have like a warning. Well, warning. This is using a lot of the RAM and whatnot. And the lower the settings, the more image you can speed out. Usually, you get around 10. Uh, the higher, the less image you can get, unless you are paying for Pro. This usually keeps this. I usually keep it around 20 or 40. Then I link a cheat sheet which can be used to see all the informations and like it's quite nice. You will have like here all the prompt stacks and whatnot. So let's quickly check it. So it will ask you for Google Drive. So you will put in whatever account you want it. Then all this blah blah blah. You're not really interested. Tutorial. If you want to check it, it's easy. You have all the settings, and you have the CP Diffusion cheat sheet. So here we start. Here you have several like ways of going through the AI. You can experiment with this. I'm fine with these. And you have all these modules which you can collapse them with these little thingies. We will go through quickly. So this you don't need it. This you don't need it. These are the settings. So for example, patch name. I don't know. Anyone has a suggestion on what should we create? Open or
Doctor Strange in the Multiverse of Madness.
okay, Doctor Strange and Multiverse of Madness. Cool. Steps 250. It's fine. This with me. I don't expect to go like 2K, 4K, or whatever. It's gonna crash the machine. So just keep it like this, and then upscale with another AI software. I will link them in WhatsApp. So because I don't have them here right now. We're not making a video, so we can skip this. This is, oh yeah, you can use an initial image. The initial image, you can basically, how this works. This starts with a noise and then it goes refining and it creates lines. Let me quickly show you this. Which one is this? These are images out. I don't know. This one, maybe partials. Yeah. Like this starts like this and then goes refining and then goes on. Always be careful with images having like humans. It can get really weird. I was experimenting with what was it? Here, and this was the like these are fine, but then when you this is for example the partials for the other, and if you ask for a human, usually it will give you something straight out of nightmares. But anyway, you can use a starting image. So instead of giving you like these weird lines, it would start with the silhouette of the image that you want, and then it will start refining on top of it. So, for example, if you have a character with an armor and you want it dressed up like, I don't know, flowers or decorations or whatever, you can use that and then like, okay, spit me out something from the 1800s, and then you will have like a kind of, so you can start working with that idea. Animation settings, we don't care. Prompt, so we can. What do you want? Like a city from Doctor Strange in the multiverse? I don't remember who asked for it.
Yep, go for it.
Okay, so cityscape, alternate dimension, mirrors, Doctor Strange, yeah, liking, I don't know, I don't remember the upside down reality in Doctor Strange, fractals.
Welcome.
Yeah, a lot of them. And yeah, that's it. Random art station. We don't really care. And the yellow colors thing, please now. Okay, this should give us something. Then diffuse. Oh, here. No, wait. Just a second. Extra settings. Intermediate saves. We can decide how many. Let's say 2. I see power. It's a city, so let's go with 35. And this one is gonna go 50,000 city. Numbers of batches. This is like how many images it was spit out. Let's say 2. Okay, so we are ready, and what we do right now is we go here, runtime, and run all. This is gonna ask you like, this notebook was not authored by Google. Yeah, I know. RAM required. Okay. It's gonna ask me, do you really want to connect? Okay, here's starting. Connect to Google Drive. Boom. Boom. Then it's gonna do is all these checklists. Oh, here you can see the GPU you have. It's a Tesla T4. Kind of crappy one if we're talking like AI, but I would love to have one. It's like only 10K. So here is going to go through all of these, and when they're all marked green, it will start here, like this. We don't care. Under here, we'll see appearing the starting noise, and then we'll go refining. The cool thing that we can do is, as you see, this is a module, and here you can either throw it away or you can copy it, and you can modify it. And what you can do is basically create, if you copy the prompt and the diffuse and the settings, you can create modules within this page. So for example, if I copy these, so if I copy one and 2, these 2 cells, I can do, for example, 10 sequences, and I can, I don't know, Miyazaki, and then I can go for something completely different, and then go to, I don't know, forests and trees, and then cities, and then space and nebulas, and I can forget about it. The only thing here, so with the free one, you always have to have it open. So and sometimes like click on it or do something, otherwise it's gonna pop and say like, are you still there, like Netflix. And with the Pro you can even close it and just forget it. You come back like the next day and well, you can see the progress in Google Drive because it spits them there. And yeah, the cool thing is that you can just do a bunch of prompts and then forget about it and enjoy the stuff. Any
Alessandro,
questions? Hmm.
I think let's wait till we'll get some picture. If you can let
Yeah,
it run till the end of the workshop, and we
yeah,
will
absolutely.
we will meanwhile we'll go to next presenter
Yeah,
from your permission. So Jonas, is if you are ready, it's all yours. Thanks, Alessandro.
Thank you. Yeah. Cool. I think you have to stop sharing your screen, right?
sorry. Yeah.
Present entire screen. Cool. So you see something. You see the screen? I cannot see you anymore. Sorry. You cannot share screen.
What did you expect? Everything will work?
Oh, damn it. I think I have to. No. Mac.
Live presentations, always fun. Made it. Very good.
Cool. So now you see the screen.
Yep. Thanks.
Perfect. Okay. Hi, I'm Jonas. I think some of you maybe already know me. For those who don't, I have a background as a VFX editor, pipeline GD, and a long time ago, I used to be a compositing intern at Trickster. That was when the office was still at the old building, and there was only one neat video license for the entire office. And you had a After Effects machine running on Windows, and you had to log in if you wanted to denoise your plate, and everybody was sharing the same workstation. So that was fun. Yeah, so in 2018, I started to get hooked on machine learning and deep learning. And that's when I started with the whole topic, doing lots of reading, watching videos, all that stuff. And yeah, it's also when I started building a VFX library tool called Das Element. And yeah, basically it started out as an image classifier. And I wanted to build an image classifier for visual effects elements, like fire, smoke, debris, because all the other models and image classifiers only work on common objects like cats and dogs, but not VFX terms. The reason is they are all trained on the ImageNet challenge. I'm not sure if you know that. Basically, it's a huge data set of pictures in like 1,000 categories and organized and of like common objects. And if you search for the word fire, for example, you get the fireplace, the fire hydrant, and the fire salamander, which is not very helpful for visual effects. So yeah. All right. So for today, I first want to talk a little bit about my experience in general in building a production-ready tool. Excuse me. So yeah. So first talk about hardware, software, and a little bit about the frameworks that you want to use. And I want to talk about using it in production and a little bit about the experience that I gained. And last, I wanted to share some resources, also some resources and meetups here in Munich. I don't know how many of you are in Munich. And yeah, let's see if we have time for Q&A. All right, hardware. I think everybody of you know GPUs, which are great for running these deep learning models. But the demand increased so much for machine learning and deep learning that we, like the processor unit developers now also developed stuff like a TPU, which is a very good working with tensors. I think last week you talked about all that stuff. And also the DPUs, which is a data processing unit, which is basically a cluster, like a multi-core CPU that is very good for pre-processing data for the entire machine learning, deep learning training in the end. Frameworks are basically, they abstract all the mathematical problems for you already. And I think you maybe have heard of some of them. The most two famous ones, I guess, are PyTorch and TensorFlow. It's a little bit about like a battle, which one you use. From my experience, most research work is done using PyTorch, and models actually being used in production, that's all done with TensorFlow. The Nuke copycat node works with PyTorch models, so you can download models for PyTorch, implement them in Nuke. The issue, however, if you have a great model working in TensorFlow, you have to adapt it to PyTorch. So let's see if Foundry is expanding and adding more frameworks. All right, models. I think you discussed a little bit about that last week. Models are basically algorithms packed together, doing magic things. And there are few resource pages where you can get these models. Hugging Face, for example. I think they got founded for 100 million, like just this year. And it's a platform to deploy models. They also do some developing their own and some research. Another web page is, for example, Model Zoo, where you can download the models from someone who already trained the models, who did oral research, and basically it's just ready to use, which can be good in most cases. GitHub is another source, and here it's getting a little bit more interesting because the models that are pre-trained are basically like a black box, and either it works or it doesn't work. And at some point, we want to start customizing further to really adapt the machine learning models to our needs. And GitHub gives us often like the link to models and training sets, but also the code. And the code is what we are basically interested in. And another great resource is papers with code. So here you get the scientific papers. If you really want to dig in and read up on what's actually happening behind the scenes. And you also get the code repositories and sometimes training samples. And I think many people use like pre-built models, which is great. But at some point, we have really start customizing. If you think about deepfake, it works great with humans. But what happens if the next project comes along and you have to make a cat or a dog speak, and you don't have enough budget to do all the 3D animation and all that stuff? So maybe you want to do a deepfake on a cat, but current models of deepfake don't work. So at some point, you just have to start customizing. A good way to start, if you don't want to set up your workstation, because it can be a little bit of a mess from time to time to get everything up and running. So a good starting point is just to go to AWS, Google Cloud, and you can start up pre-built workstations with all the GPU drivers and CUDA installed and all that stuff. So it can save a lot of time and headache. Cool. Everybody's talking about machine learning and deep learning all the time. And I think most of the time they mean deep learning, because when you think about machine learning, there's much more to it than just the latest mid-journey models or whatever. I think personally that you really have to understand all the machine learning models, because deep learning is just one part of them. And deep learning works great for certain use cases, but sometimes it's better to use a simple approach and some other machine learning algorithm. It's the same with compositing in Nuke. You don't go into 3D projection and deep renderings right away. If you can simply solve it with like a 2D track, you know, keep it simple, understand everything to then come back and do a simple solution. I don't know how many of you have heard of other machine learning algorithms like random forest and decision trees, principal component analysis. And all of these machine learning algorithms are there for like years already and good in solving certain problems. So don't always jump into deep learning right away, because yeah, maybe there's like a much faster, simpler solution. All right. So a little bit about my experience using or like building up an image classifier that is production ready, I would say. Last time you discussed convolutional neural networks, I think, as well, which are great to do image classification. You know, you have like a 2D image, you run it through a bunch of layers, like 3D convolutions, pooling, and whatever. And in the end, you have a list of labels, which are basically the categories that you used to train the machine learning model, the deep learning model. And yeah, that's great for image classification. Some of you already heard of transfer learning. That's basically you cut off the last layer with all these single labels, and you provide the model with your own labels. The cool thing is that because it already learned all the features, you can basically just exchange the last layer, the last output, and provide it with your own labels. So the deep learning model can use the previously learned features and just apply them to your ones. Cool. Now it's getting a little bit more interesting, because if you cut off even more of the entire classification part, you can get to something called like the feature vector. So the feature learning is in that stage has like 3D multi-dimensional features that it learned, and that's what we are interested in. Maybe you have heard about the autoencoder network, which is an encoder and a decoder network working together. And in the center, we have the latent space, also referred as the bottleneck layer. And what it does is it takes an input image and it breaks it down into the semantic meaning. If you think about translating from one language into another, it's basically the same. So you take the input language, you break down the sentence into its semantic meaning, and then you can basically decode it into any language as you like. And the same works for images. So we are interested in this latent space bottleneck layer. And we go back to our convolutional neural network. If we cut off the whole classification part, we add some more layers ourselves, we can output a 2D array, which is just a list of numbers basically. And that's the semantic meaning of the image. And now we used a deep learning model, but we continue now with a regular machine learning algorithm, which means we can apply something called K nearest neighbors. I think the guys in the pool sum it up pretty well. The feature vector is just a big list. And if you have two lists, you can compare them to each other. And if they are somehow similar, they are most probably in the same category. And if you have feature vectors that are very far apart, you can tell, okay, these are not in the same category. There's a cool GitHub page. It's called Annoy. It's a Python module. I think it's developed by someone from Spotify. And it allows you to break down all these feature dataset points into categories. So we can train our deep learning model to make predictions on a predefined dataset, but by using this approach with these feature vectors and then the k-nearest neighbors, we can also add new categories without having to retrain the model, which is, well, we just apply it to an incoming image, we get the feature vector, we compare it to all the other feature vectors of our existing library, like element library, and then, we can classify an image without having to really run it to a deep learning network, in a sense. Cool. So important part is, don't always jump into deep learning. Learn about machine learning algorithms, and see if there's a simple solution, which is also much faster. The key point of everything is training data. If you have these image classifiers, and I don't know, it's like ResNet and AlexNet and whatever all the names are, basically they beat each other in like 3, 4, 5%, making better predictions. But only if the training data and the training set is good. If you have a crappy training set, well, you're screwed. That's why most of the time goes into really organizing all the samples, getting all the pictures, images, whatever, organizing them in folders, providing them with labels, then so you have good training set. From my experience, 90% of the time you spend organizing stuff, and 10% is just running a machine learning model. So lots of organizing. Cool. At a film school here in Munich, there's now a student project, and they're using style transfer, which means it's a full animated short movie of like 3 minutes, and they render everything with Blender. And for each shot, they take 3, 4, 5 frames. They paint over in Photoshop to get like an individual look. And by using a predefined model called Absence, like a little tool you can download, it interpolates these start frames for the entire shot. It works quite well, but you realize there's still many issues. For example, they are using it on Windows, and it breaks very often, it crashes, it requires a very specific file naming, it only works with PNGs and not EXRs. So the models are there, but again, at some point we have to customize it and really make it production ready. And my personal advice is learn scripting, learn Python if you're really serious about machine learning. In general, learn Python. It just helps you with day-to-day work. But if you can go in and really customize the models, I think the model before had like a resolution issue. And if you want to render a 4K image, at some point you just have to customize the models to work with high resolution or whatever. Learn Python. Cool. Are we in time? Just wanted to share some resources. I think most of you know like Runway ML, TechVar, and the Rotobot model. I like TechVar a lot. It's developed by a guy called Vladislav. Super nice guy. The cool thing is you still have all the control inside Nuke about all the keys, which is interesting because the other models just give you an output and you have no control anymore. But if you have all the keying options still inside Nuke, well, that's pretty cool. How many of you have heard about one-shot video object segmentation, or SOF? There's also a follow-up paper. Actually, it's automatic rotoscoping, and that one was developed in 2016, 2017, and it's actually developed in Munich by the Technische Universität. And I don't know why I just stumbled upon the paper like 2-3 years ago or whatever. But the interesting is it's developed just around the corner and I didn't know about it. And I think it's so important to look outside the box and revisit like what other industries are doing, because most of the time they try to solve the same problem. If you think about autonomous driving, cars detecting people running around, they have the same problems as we have in visual effects. And basically they have more money, so they can do more development. So yeah, go look what's out there in other industries and bring it back to visual effects. So last slide, just 3 interesting resources, 2-minute papers. I liked it a lot. It's a guy representing and visually displaying in like short video clips the latest papers in research, which is pretty fun to watch. The AI podcast, which is most of the time also dealing with visual content and like media content, which is also pretty cool. And also my favorite one here in Munich, the local meetup group called Munich Data Geeks. And again, people from other industries gathering around. They are not so much different from visual effects people. They like beer and pizza, so that's good. They had a break during COVID, but now they are back in doing live sessions. And it's really fun to go there, meet people, learn from other industries. I remember one meetup when I was talking to someone doing lens distortion for cameras of autonomous driving. And I told him about like ST maps. He was like, huh, what's ST map? But I think it works the other way around. Like we can learn a lot from other industries and adapt their knowledge to our use cases. Yes, and that's about it.
Cool. Thank you, Jonas. It's very cool to see that. I think we will see now quite some parallels with the next talk from Lukas regarding the deepfake stuff. But thank you very much. Very interesting. I wrote down all the companies. So now my research next time. I think Lukas, it's all yours.
Cool, thanks. Yeah, so I'm gonna talk about deepfakes because I guess you can't talk about machine learning and visual effects without talking about deepfakes. And first of all, I have to say I'm not a programmer like Jonas is, so I'm sure he can explain everything much better than I do, because for me, like I explain it just as a very simplistic version, how I understood it. Because all of this AI machine learning stuff is quite a black box to me that is just doing some black magic. So yeah, what is deepfake? A deepfake is a face swapping algorithm that uses neural networks to map one face onto another one. And here, for example, we have Chris Evans on the left and a picture of Brie Larson on the right. And we want to map out the facial features from one image to the other one. So we want to have Brie looking in the same direction as Chris and having the same lighting situation, having the same facial expression, having the mouth open at the same time, or the eyebrows moving or stuff like that. So the whole deepfake workflow consists of 3 parts. First, we have the detection and the preparation of the faces. Then, like that means not only the faces that we want to put on our body, but also the original face. So we need the face of Brie Larson and the face of Chris Evans prepared. And then we have the training part, where the software learns both faces. So it learns every lighting situation, every facial expression, every angle of the source and of the destination face. And finally, we have the merging part, which is basically just the export. So yeah, first the facial extraction. So we need to detect the faces in the images, and we also have to align them. Aligning means that the software recognizes the basic landmarks, so the eyes, the nose, the mouth, and the eyebrows. But also we have the face segmentation, where the software learns if a pixel of an image belongs to a face or not. And then this gives us a mask that can be basically used as an alpha channel. So how does the neural network do this? As we, as Jonas explained before, we have an autoencoder, and this autoencoder has three main parts, which is first the encoder that takes an image and compresses it down and does all sorts of stuff to it. Then we have the bottleneck, which is the the interlayer that gives us a compressed representation of our data. And finally, we have the decoder, which is actually doing the exact opposite of the encoder. It takes whatever it gets from the bottleneck, from the interlayer, and turns it back into our original image. So the goal of an autoencoder is basically to take any input and reconstruct it as best as possible. So why do we use actually the autoencoders? The important part is the bottleneck, as I said, which gives us the information that we need to decode the faces then. It's basically like the software learns how to draw faces actually. It's like if you give a person a bunch of pictures of a dog, and then the person learns how to draw the dog, and then you give them a bunch of pictures of a cat, and the person learns how to draw a cat, and then you tell them to draw a cat, but in the specific angle or pose or lighting situation of a specific dog. I hope that's not too abstract, but this is basically what it's doing. So yeah, you send in an image, and it learns the face, and then it will focus on the main features. It compresses it down, and then you have a decoder which is specific to that face. So you have the decoder of Brie Larson, and you have the decoder for Chris Evans. So to swap the faces, we use the encoder and the bottleneck of Chris Evans, but then we use the decoder of Brie Larson, and what we get is basically the face swap. So the software actually doesn't know that it's even looking at faces. So to speed up the whole process, you can start a pre-training where you feed it just a lot of generic faces. So it knows how a face looks like, and this will just speed up the whole deep faking process a lot. So when we have the pre-training and we know how a generic face looks like, we feed it with a lot of different angles and lighting situations and expressions of our faces that we want to use. And obviously 4 images won't be enough for that, so you would rather need hundreds or even thousands images. If all of those thousands images are prepared, meaning the faces are extracted, aligned and everything, and we have the generic face trained, we can start with the training of our specific model. Here we have, for example, the source face, which is the one that we want to swap to. So here you can see the original image, and then we have the computer-generated decoded image of the source face. Here is the same for the destination face, which is the face that will be replaced. again, the original image that we fed into the autoencoder, and then the decoded image. And this would be our final output. So we have the original image, we use the encoder and the bottleneck of Chris Evans, and then we use the decoder of Brie Larson. During the whole process, there are actually two AIs working. So we have one AI that is trying to draw the face, and then we have another AI that is checking constantly if the face that is being drawn looks like the original image. So this will give us an error rate. And in the beginning, the error rate you can see up here, it's the blue and yellow graph. And in the beginning, the error rate is quite high. And also you can see in the beginning, it's more of a blurry blob instead of a face. But after weeks of non-stop training and a couple of 100,000 iterations, we get out a quite nice looking face. So yeah, that's the training, and after the training we have the merging process, which is, as I said, basically the export. And here the deepfake software gives us kind of I would say a low-level compositing software. So you have a lot of adjustments like blurring and sharpening and scaling the face and extending the mask or adding motion blur, changing colors, stuff like that, to just bring it closer to the plate that we want to put it in. But in the end, I would say nothing can beat a real compositing software, which is why we here at Trickster, we export the raw faces, which is without any colors and blurring adjustments. We just add a bit of resolution, which is AI upscaling to get a bit more of details, but the rest is done in Nuke then. And yeah, that's basically how you put Brie Larson on every adventure in case you ever need to do that. So yeah, that was it. If there are any questions.
Why is this so haunting?
Oh, sorry, excuse me.
Small one.
Yeah.
How does the computer know if what he did is right or wrong? So you're saying he's doing 1,000, 1,000,000 iterations, and how does it know what to keep from the iteration and what not to keep? Like how?
Yeah, this is basically what. That's basically what the second AI is doing, which is just checking. I guess it's kind of a. It just checks how close the images are, basically. Like I say it in a very simplistic way, but just doing a difference and see how much difference there is. And like this is the error rate. So the lower the error rate, the closer we are to what we need. If that makes sense.
So basically, it's creating a pathway to create a copy of what he got and then running the other face through that same pathway.
Yeah, that's how I would say it.
Correct.
Yeah.
Maybe.
Okay, cool. Thanks.
So basically, what he is doing, and Jonas, correct me if I'm wrong. So all the point is that you saw already this graph that going from left to right, that we have the image input, then this image input is stripped from a lot of details, and we staying with very little amount of details in the middle of this image input. You remember, in the middle of the neural network. So we're staying only with the really letters that describing this image. That's called the bottleneck. Okay, so we cannot go just from X to Y directly, from one to the other, because we can just say, well, we will just copy it. But basically then we will be able to produce just this picture, but we will not learn in the middle general idea of this picture. And when we're stripping this picture from the a lot of stuff, and that's what like convolutional neural network is doing basically, it's extracting just very precise details, and then it's saying, well, now after we did strip that, let's have a look how good we did strip this and how good we're rebuilding that. And in the beginning it will create crap, but then it will make this back propagation. He will go to the same pixel and run it backwards to the original image, and then he will make again through this bottleneck. So he will kind of like say, well, I will strip everything to the very basics of this language. Then I will recreate it with my decoder. And then that's the picture. Okay, that's the picture. Then we will sample the picture that we created and we'll run it back through the decoder, through the bottleneck same language, back to the encoder and back to original picture. And then we'll compare, okay, with our encoder decoder kind of process, we created certain picture. And then we'll compare it to original by running back the same algorithm. And then original will say, well, no, we way brighter here. Okay, let's go minus 0.5 by brightness in this pixel, and running this again by same encoder. And that's how we slowly descending to the right solution. Does it make sense? And Jonas, correct me if I'm wrong, but that's basic thing how actually, and that's how we're learning the language. We're not just learning the picture to copy the picture, but we're really learning how to recreate all the main letters of this picture, main signs of this picture, symbols.
All correct. Basically, it's called a generative adversarial network.
I have a question. Can you not simplify the process for the encoder by creating a specific shoot of the face that you want to be mapped onto the target face by using, for instance, the facts, facial expressions? Maybe you choose, you follow the 52 facial expressions and you photograph those from various angles. So you've got a very specific data set that you're feeding the encoder, and you've got all the specific expressions and facial, positions that you want. So you've limited the amount of data that you're feeding to the encoder, but you'll still get the result that you want for the target face. Is that possible?
Yeah, if you have access to exactly those facial expressions, that would be the best. But like in the most cases, you don't really have that, except if you can, like if they're still shooting the movie and you can ask for exactly those things. But
okay,
usually when you just use a random face from a random actor, like all the YouTubers do at the moment, you just take whatever you have, which is basically everything from a movie, I would say, or from a TV show or whatever. So you just take what you can get. But
yeah, exactly.
You're right. If you have access to art direct what you get, that is the best case actually. Yeah.
Fantastic. And I do have a follow-up question. At the beginning, you showed us the different types of neural network and ML systems that are out there. Would you say that there are some that are easier to use than others?
That would be a Jonas question, I think, right?
Okay.
I think they're all easy to use. I think if you want to customize it, that's a tricky part.
Okay.
Like understanding what they are actually doing if they don't produce the output you're looking for.
Yeah, so you have to learn to train it.
Yeah, it's like rendering a pre-comped nuke script. Yay, it works. But if you want to change something, you have to learn nuke, and it makes sense.
Yeah, that makes sense. Also, I love the cats and dogs analogy. It was brilliant. Thank you, Lukas. Also, one last question. Once you've actually got the face and you've got the merge, is there a way of creating an automatic alpha channel for the face?
You do get an automatic alpha channel, which is the segmentation that I mentioned, where it just checks if this pixel belongs to the face or not. But often it's quite good, but often you have to rework it and maybe to do a new alpha channel at all. But you get one.
Brilliant. Okay, thanks, guys. That's me over.
Yuri?
Yes, question from my side. Is there any way to get some technical paths from whatever has been analyzed, like a local position path, some UVs, some vectors, anything?
Not from the software that we are using, not from DeepFace Lab. I think there are some developments going on at the moment. I'm not quite sure, but I think I've read something about getting out a 3D model even. But as we have it now, no, there are no technical passes, unfortunately.
It's not out of the box, but the one thing that I'm pretty sure we will be able to get out is the segmentation, because inside of the box it does segmentation for eyes, nose, and lips. So he's able to define that, meaning that information is there. But again, that's kind of connected to Jonas when he's saying, well, if you want to render the pre-comp, go for it. If you want to go inside and extract some DI mats, you need to understand what's happening inside. And that's starting with
because
hardcore.
Because DeepFace Lab is extracting the maps, the segmentation maps, like eyes, mouth, but maybe there is some machine learning software that is actually exporting the positions, the vectors, because it's way more useful than just a map.
Well, maybe, but that's I don't know.
Jonas, maybe?
I think if you look at like all these, I think there was a video about relighting, like a novel approach, and basically they had a combination of, I don't know, like 10 different algorithms combined to each other and then reorganized and mixed together. And it was like each model, machine learning model or deep learning model, was doing one task, and one task,
right.
And then you combine them. So it would be just a job of finding a model that's very good in creating, you know, UV coordinates from a face or whatever, and then providing one input into the other and then building a chain of operation.
Okay.
Yep.
Okay, so it's pretty complicated. The state of art of exporting information is
it's in general, like what I have feeling with, I mean, that's more on the, again, way more philosophical level, that not just connected to us, that if you want to stay on somehow on top, you really need to learn, because all the guys, the smart guys that are doing this AI will make it very simple for us. We will go and we'll type beautiful city, and then we'll be posting pictures on LinkedIn and saying I did art. But actually it's if you want to go to next level, which is more adjust stuff like that, and that's what will be the top, I don't know, 5%, that's starting to be very tough. So but like I think that's why we need really to Python and so on. You cannot escape that. I feel that it's otherwise you're staying with the people that typing just beautiful words, make beautiful shot and stuff. I'm not kind of like, I'm exaggerating right now, but it's really going quite strongly now to tools getting so smart that we kind of like starting to, we don't need to be smart, we just can do stuff easily. Anyway. We were running like a little bit behind 10, and I think we already started morning meetings in company. I would like to thank you, all the speakers. Thank you very much, guys. It was extremely interesting. I will record this. Basically, the recording will stay at Trickster, and also we'll post it in our WhatsApp group, so you can rewatch it if you would like to. Thank you very much.
Thanks, James. That was the best one yet for me. Thanks a lot.
Thanks.
Great.
Thanks.
Thank you, guys. Bye.
Thank you. Bye.
Bye-bye.
Okay, and Stop recording. Of course.